This time we have a spot welder to unbox and demo, and this thing, it puts out a lot of power. I was quite impressed. I was welding steel pieces of metal together, and then of course putting the battery tabs on onto rechargeable batteries like lithium batteries, putting the little copper strips that are used to attach batteries together and make a battery pack. Anyway, this came from Banggood. Let's check it out. This is the official unboxing and demo of this inverter energy welding machine. It's a spot welder. It's from Litter. I got this one through Banggood, and we're going to try it out. I've got some scrap metal. I'm going to try doing some welding on that, and we'll even try attaching some tabs to batteries, because that's where they come in real handy when you want to attach wires directly to batteries. To build battery packs, for example, you can't use a soldering iron because it'll transfer too much heat and could potentially cause a lithium battery to spontaneously combust. And this gives you intense heat, but it's very quick, so it spot welds. That's what these do. That's what a spot welder is. Anyway, let's unbox this together. I have no idea what's in the package. It was left at my door at like 11:20 last night. I already have roasted the delivery driver for that. We've got a box here and a box within the box and some inspection and so forth, and the actual user's manual, which I intend to read because I've never used one of these before, and the unit itself. So let's just lift it out. It weighs a few pounds. Feels like it's got some weight to it. It's got some parts in it, obviously. Let's just get the plastic off of it. You put them on the same terminal. You don't put one on the positive and negative when you're spot welding on a battery. You have to touch the same electrode of the battery. Duh. Here's going to be the power cords and some more literature. What do we have here? We have a foot switch to operate it so that you can hold the probes in place and step on the foot switch. Comes with a grounded power cord, just a standard type of cord like you'd have on a computer. And of course it comes with some chunky cable. Now that is, look at the size of that copper. Holy crap, that's like a ½ an inch thick. That's the welding cable. You know that this thing is going to put out some serious amps. What else do we have in here? We have copper to put onto your batteries. That is what you weld onto your batteries to fuse your batteries together. That's heavy. That's solid copper. Comes with some more welding probes for, I guess, when you burn your probes out, you can replace them. Oh, they're smaller welding probes. And then there's this one here. So these probes are for the milliometer to measure the quality of your weld. It'll actually measure the resistance of your weld itself. What else do we have here? There's got to be other stuff in the bag. So let's just complete the unboxing and see what other accessories come in here. Oh, these are metal strips, and these are metal strips. So these ones here, this was a roll of copper, but here's some more strips that you would weld onto your batteries for putting batteries together. Presumably you can buy these consumables, but that's what that is, right? 5 meters of copper here. This is quite heavy. Time to read the instruction manual so that I can figure out how this thing works, so I don't electrocute myself or burn the house down. So obviously this has got big capacitors in it. We're going to open this up too and take a look at it. Here is the, it takes 18 minutes to charge this thing up, to charge the capacitors up in there. Oh my God, they must be huge. The welding voltage is between 5.6 and 6 volts, so you're not going to get shock from this thing. Okay. The charge current is 10 to 20 amps, so I have to plug this in directly to an outlet, not on my transformer, otherwise we'll just burn the fuse out on it. This is the welding power. This one is 42 kilowatts. That's the one that this one is. 42 kilowatts. 42,000 watts of power for spot welding. And you've got an auto trigger or a manual foot trigger. And it says here, phosphate iron lithium power battery aluminum to copper welding machine. So these are aluminum strips, these other ones here. Welding voltage is 5.6 to 6 volts. 7,000 amps pulse. Holy crap. 7,000 amps this thing will deliver at 5.6 volts. Like, we're talking a lot of energy on this thing. I mean, this is ridiculous, but it should be pretty cool. Normally I would, of course, do the product demo and try it out before taking it apart to see how it works. But I think in this case, I think we're going to take this thing apart and take a look inside it first before I even power it up, because this is going to have large capacitors in it, and well, they won't be charged at this point, but once I put power to it, there'll be a charge on capacitors, and I would rather not get my fingers, even though it's only 5 volts. If something were to short out, it could have a big problem. So I think before I even plug it in, we're going to take this thing apart, and we're going to look inside and just see how this thing's built. What do you guys think? That sound like a good idea? Why am I doing this way? We do have power tools here at the shop. Can we open this without breaking that seal? Oh, it says void. I voided the warranty. I voided the warranty. Oh well. Alright, here is the, well, it's got 6 humongous capacitors in here. Look at the size of those suckers. Holy crap. Here's our power inverter on the front. And, well, the back, you can't even see them. This is all sealed up. But it's got a power inverter in the back and so forth. There'll be a fan in here somewhere too, I'm sure. But that is the capacitors, and these great big, these are probably IGBTs or something that can handle a lot of current to trigger the. Obviously, not going to do it with a relay or something, because the contacts would just weld shut. But you've got all these IGBTs or some type of a solid state switch on the side here. Little fan on the back to cool down the inverter. And this is the capacitor bank. And I'm not going to take the capacitor bank out. Can we see what the ratings of them are? I'm just trying to look in the side here. See if I can spot what the ratings are. I see them marked with a positive terminal. What are these? It says, warning, do not exceed the maximum voltage. They are, what are these things? They are 2.8 volts. I can read that much. Looks to be 30,000, what? No, it's gotta be more than that. I can't read all the numbers here. I'm just trying to see the numbers on these caps. And you know, I could get my borescope in there if I really wanted to see what they said. Stick my little borescope camera in there, but they are 2.8 volts or 2.6 volts. Did I say 2.8 volts? So there'd be 3 of them in series. 30 something, 300, 300 something, 3,000, looks like 3,000, maybe 3,000 farads. I don't know what these things are. Can't see the other side of them here, or can I? I can't see the other side, but they're big, and they're in this solid aluminum chassis, which means that it's probably, in case they explode, to try to contain the mess that these would create if one of them were to pop. But my God, these things are huge. Like, these caps are about 4 inches, 4 inches long and at least 2 inches in diameter. Okay, well, I don't know if you guys can see that any better, but can we see it down here? Probably not. Anyway, positive terminals on this side, I know that much. But they are big. Hence why it takes so long for them to charge. The welding probes go on the front here. You put them in the front and screw them down. They go in there and they're held in place with screws. I'm going to put the cover back on this thing, and we'll get it charging up and see what we can see what damage we can cause. First things first, I'm going to throw the top cover back on because there really isn't a lot to see in there. So these little test probes, these are for testing the quality of your weld. It looks like it uses an S-video connector. It is an S-video connector. It just plugs in the front there, and it'll test. It's a milliohm meter. These big chunky cables plug in, and there'll be some screws to secure them because you don't want these things coming loose. So we'll just remove this silicone cover, and we'll put the two probes in and secure them. Jeez, these things are heavy, these cables. It's like, they probably go up like that. They probably have to go up this way, otherwise you're never going to be able to plug that little probe in for measuring. So I'll throw the screws in, because God forbid you don't want a bad connection on this, that's for sure. Not with the amount of energy this thing's capable of putting out. Tighten down those screws good and tight. Now there's an automatic and a manual way. The automatic says it does it automatically when you push these down. And I guess when it senses you have to push them down quite firm. And when you push these down, then it will trigger in half a second. It will trigger automatic. I'm not going to do that. I'm going to, I'm going to use the foot switch, because I think that is a better way to do it. You got the foot switch there, and then once you're ready to weld, you just step on the foot switch. The foot switch plugs into the back and obviously sits under your foot. Duh. So we'll plug the foot switch in. I'm going to grab a couple scrap. I'm not going to solder, I'm not going to weld batteries immediately. I'm going to try welding on, well, there's my camera cable falling down. Still using the alternate monitor, as I haven't got around to fixing the LCD yet. But we'll power this thing up. It's going to have to charge. It says it's going to take a few minutes to charge. So I'm going to power it up to full AC. We're going to let this thing charge, and then I'm going to test it and see what it does. See whether we can make some smoke. We'll turn it on. There we go. Okay. It is now charging. It says charging. This is our voltage. And this has got to get to between 5.6 and 6 volts. It's set for a 10 millisecond charge, and this is going to take several minutes to fully charge for the first time. As you can see, the voltage is very slowly rising. This will measure the total resistance value too. It's a milliohm meter, so if I were to plug that in, I could probably measure milliohms right now with this thing. What happens if I short these probes together? Will they measure? I don't even know how these work. There we go. 0 ohms. Anyway, these are for testing. You put these onto your welds after you're done, and it will measure the amount of resistance. Of course, what these are really designed for is attaching your tabs to your lithium or nickel cadmium or nickel metal hydrate batteries that you're using to build battery packs. That's what these are used for, because you can't solder on here. If you put a soldering iron on here, you'll create so much heat that you'll kill the cell. So you have to spot weld them. That's what a machine like this is primarily designed for. I'm at 3.2 volts now. It's been going about 10 minutes. And I'm going to, once it's charged up, I'm going to try to weld these two metal plates together. We'll do some spot welding on here and weld these two steel plates together and see how that works out. And then I'll try attaching a tab to that battery. So again, it's slow to charge. I don't know how long it'll be between each cycle. I'm sure it's going to be faster between each cycle, but we're going to weld this together and see if I can pry it apart. And And the same with the tabs. Obviously, we'll be able to pull the tabs off without too much difficulty. But I want to see how strong this will make it. And we'll go from there. I'm at 3.4 volts now. It's got to continue to charge for a few more minutes. I can actually increase the duration. It's at 20 milliseconds now. If I press the button here, I can maybe take this up to, I'll take this up to, I don't know, I can go as high as 90 milliseconds on this. 90, we'll go higher than that. Might even go to 99 milliseconds. I'll bump this one up to the longest it can go to, because this is pretty heavy metal. And a battery, obviously, you're not going to do it that long because you don't want to transfer any heat into the battery. But we'll crank this sucker up to the maximum it can go for to try this. Should be interesting. I can't wait. 3.6 volts. We're going to crank this right up to the maximum 6 volts. We're getting there. We're at, it's kind of hovering between 5.5 and 5.6 volts. So it might have enough juice in it now to attempt to weld this together. It's welded. They welded it. Excellent. So we'll just do a few more just to give us more strength. That's amazing, the amount of current that this thing, it's at 6 volts now. We'll just do it again and hit it again and go. And a few more times here. This thing, when it kicks, these cables actually jump. The amount of current that's going through this thing, I can feel the cables jump. Amazing. Okay, I think I've made a point. That is spot welded, and that's not going nowhere. See if I can break this free. I can't bend the metal. Yeah, it's done. It's done. That's not going nowhere. That is that's welded. That's spot welding for you. Very cool. Very cool. Let's turn this thing down a bit. I don't think I need to have it all that high. Let's turn it down to, let's see what 10 milliseconds does on the same chunk of metal. See how that looks. Yeah, even that is, well, I don't know if that would weld this, but certainly the longer one did. But that's not what I'm going to try. I'm going to try to spot weld a tab onto the battery. And I've got it down at the minimum setting. Spot weld a tab on, as that's what this is designed for. It's designed to spot weld tabs onto batteries. So if I put my I'll put a tab on top here and put my probe on there and grab my second probe and put my second probe next to it, and then while my second probe is there, tap the foot pedal. And I've now just spot welded a tab onto the battery, and we'll do one on the other side. Now you can touch these because you're not going to get a shock. It's only 6 volts. So it's not like it's going to kill you if you touch it. And then I just spot welded the other one on. And that's what these are designed for. These are designed to put tabs onto your batteries, which is what I just did. And then of course I could solder wires onto these tabs and install this into a piece of equipment. That is, in a nutshell, what this spot welding machine does. Now you can use the meter to measure how good your weld is. Because you put one probe on the terminal side of the battery before you welded it, and the other one here on here, and it's looks to be 0.1 milliohms. 1.5 milliohms. Actually, no, it's, well, you see that it's less than 1 milliohm. So that would be a good weld. This one should work. There. Now it's on good. That ain't going nowhere. That's welded. That's welded well. Anyway, this was just a, and of course if I put it in auto, right? I had it in manual where it's stepping on the button there. If I put it on, auto, it just does it automatically as soon as you place your probes on. As soon as you place your probes in place, it does it automatically. Does it in half a second. That's when you're doing a lot of spot welds and you just don't have time to be stepping on the foot switch. You can select automatic. Anyway, I think I've demoed this as well as I can demo it. It's a spot welder. It's designed for welding pieces of metal together, welding tabs onto your batteries, and well, it works. It works. I'm going to throw the link in the description. Say it's not cheap. It's an expensive piece of equipment, but it's certainly very functional, and it's lived up to my expectations on for everything that it needs to do. I'm going to switch this thing back to manual here before my probes touch together and weld themselves together here. So put on manual, so at least accidental of the probes is not going to set it off, because it won't go. It won't go until like the probe. It has to measure resistance before it'll go. If I step on the foot switch now, it'll just say error, because, and see it lights up switch when you step on it. It lights up error because there's nothing to do, right? Nothing to do. If I go back here and put my probes on the metal and then step on it, and that tells me Ka. I guess that's how much juice it shot through the metal here. At 90 milliseconds, yeah, the metal is warm. It heated it up. It heated it up quite nicely. But as you can see, it's done. So I'm going to throw a link in the description. Came from Banggood. I'll throw their link in. This looks like a very cool piece of equipment that I'm going to look forward to using whenever I need to do any metalwork, like for cabinets, putting together cabinets, so forth. That will come in quite handy, I'm sure. Thanks for watching. We'll catch you in the next one. Bye.